The foil system also developed, because the HysoCat system, that's what we're calling, I just described it, is the basic one, and most ships are faster, not very large craft, is the best solution. But once we came to workboats, which normally don't want that very high speeds, but they want low fuel consumption, they run at lower fruit numbers, foil systems must become different. Already, when you work a foil system out, that applies even to an aircraft. When the aircraft goes fast, it has much smaller wings. When it goes slow, it needs much bigger wings. When it lands, it must go slow. To be able to land, it drives flaps out to have larger wings. The same applies to the HysoCat. So we developed this low-speed craft and called the tandem foil system. So we have two foils spanning the tunnel, not anymore the little trim foils, but a load-carrying foil at the back as well as in the front, which moves a little bit forward. And we prefer to have the rear foil adjustable, because at the lower speed, trim adjustment is very important. And these foil systems were used in many workboats now. And the largest one is possible, the Geo shipyard in America building a 24-meter ferry through Viking FCS. And that has a tandem foil system of this kind. It's not the first one, but possibly the largest one, and it's in operation for a few years now. Because when you have a ferry half occupied, then people all go in certain corners where they can see better, or they made a mistake to put a little restaurant in the bow, you know, so that was always occupied and trimmed about badly. And with an adjustable foil, you can compensate that, you know. Without that, you must shift the center of gravity. On the other hand, tandem foils are less efficient in total than a single foil. But when a single foil gets too large, and remember, we cannot extend the tunnel width of the ship as we would like to, then we get a very big cord length. That does not make very efficient foils. Even they bring some advantage, but not these huge advantages. So there is suddenly another foil system. So I had to extend my mathematical program and so on. We got that also very fast under control now. Then we came to these high-speed ferries, which have semi-displacement hulls. Australia and Norway are the main contributor to that technology, which is also driven very far. And they are running now at very low fruit numbers. But first we thought, no, we can't improve them. On the early stage, we refused to go for such projects. But on the research side, we started with it. And Sir David Brown still wanted to build a yacht after his boat, which was called She Flying Sun in Monaco. He wanted a 50-meter boat, so that would fall in that range. So the first model tests were done for such a design, proposed by Nigel G. again, but it only went as far as a model, and we put different foils on it. We could not get much improvement with the standard HysoCat system. The tandem foil system brought a bit better improvement, but then we dropped the main foil, put it more forward. So the main foil could now, because being under the keel, have a much wider extension, had a much better aspect ratio. And a rear foil was needed to balance now the big forces on that. And we got improvements like on the HysoCat, 40% on these big ships. From there on it started. Later we got a project with Halter Marine. It's a foil system for ECAT, which went from, which was for Halter Marine actually, as I mentioned, the model on the sea. So they were very willing to work on it, change things. So without touching the propulsion system with water jets, that was all left the same. We put the foil system on. We brought the ship from 31 knots to 42 knots with the same weight. And when we had less fuel in, it went up to 46 knots. And the whole boat was carried out of the water in front. And you can see such photos in our publications or on the website. And it worked actually surprisingly well. And Hoppe Marine was also very interested to go, but we didn't know it at the time where they were on the road of bankruptcy. And after the ship was finished, a few months later they declared bankruptcy and they closed the fast ship division totally down, and the rest was bought out by a Singapore company who were only interested in the oil supply equipment what Hoppe Marine produced. So the big effort we put in to transplant that project to America failed because the ship was never used again and might stand around somewhere still. So that was very disappointing for us, but at a later stage we got a project which went still through the University of Stellenbosch. It was not treated very well. Even I had worked a lot for it to get the Chinese interest. I sent twice groups of engineers over to discuss these things, and one day they went for it, but they expected that the university would finance a project to put a hydrovac, this foil system we called then hydrovac. It's not my invention, don't even like that name, but because what means hydrovac? Water, foil, watercraft, you know? So we call it hydrocraft. It's much more precise, you know, for different systems than the hydrocat. But they went for it, and a project was done, model tests were done. They showed that a ship, what they were running with 14 knots, could be brought to 15 knots. This ship had gas turbines and enough power reserves and water jets from Kameva. And, but the Chinese, that only turned out later, did not allow us only 3,600 kilowatt per engine, where the engines can make 4,500. But because we brought a big improvement in, the project was still followed up. The foil system was built here by, what was it, company in Cape Town, and shipped over, was installed, and trial runs were done. Ship worked very well, but then, I mean, it worked so well that we got the Marine Department approval as a ferry to operate in Hong Kong. That was all formalized and finished after extended trial runs, but we hit a problem with the water jets over 46 knots. And when we started the project, we talked to Kameva if these ships can make 15 knots at all, but the answer was not very definitive, and I have my doubts. There was possibly a limit with the water jets, but that was not the real origin of trouble in that project. The trouble was vibrations. The water jet vibrated. Where they did not vibrate at 14 knots, they vibrated at 46 knots. And we had cameras installed under the hull, and we observed some air break-in to the water jets, which came maybe from the foils, but later we found out that the hull itself produced also air bubbles, which went through the water jet. So at the higher speeds that became more, and that's why that stopped. So there was a big meeting to see what we can do, because they want these 50 knots. The Chinese are still today interested in it. And we said, no, we must go back, make a few model tests, how we can change the foil system, which was all actually very well in reach of us, and because the model existed in the tank, facilities were there, but it needed a bit research funding. And then by, I don't know what kind of decisions, the university closed the project down. So it was not the Chinese who said, close the project, we don't pay. It was the university. By closing the project by themselves down, the Chinese were not obliged to pay anything. And they were naturally very disappointed. They naturally told the university, now take all the foils off and get them out in the old stage, which cost another $500,000 for the university to do that, you know. And since then, they're sitting on the patents still. There are patents in most English-speaking countries, but they are not doing anything to solve that little problem with the ventilation. If we had a propeller system, there was no problem whatsoever. But here, it actually was so negative that it stagnated the development. But I mean, this does not affect any HysoCat development, because the tunnels have the foils, the hulls are separated from it. There's no problem with such kind of ventilation effects which might come from the forward strut of the foil. And also there was no money to make the model test to prove where it now really comes from. So it was so disappointing to be taken out of research work running 5 years by a little appearance, you know. I mean, ships have been developed and never worked, and they continued the efforts and they got them working. HysoCats sometimes didn't work, but shifting foils always got a result. So we design foils today in such ways that we can shift the foil. And it's not the fault of the foil often, it is the fault of design, development, and client wishes. Clients want new equipment that shifts the center of gravity, that would shift the foil, but they don't think of it. Put the boat in the water and it doesn't take trim up, then the foils cannot work. But with a little shift, sometimes 300 or 500 millimeter shift, and the foil works. So critical the positioning is.